A focus adjuster on there?
Yeah, I think someone could reach that. Somebody's tall, maybe. I think it's underneath.
Oh, there we go.
Looks like someone messed with this.
That looks good. Close enough. All right, so building your first app, kind of. And you'll see why I say kind of in a few minutes. So MongoDB is a database, right? It's for those of you. So who here has used either Postgres or SQL, like MySQL before, like some kind of tabular database? Everyone? Okay, so almost everyone. So it's database. So we're trying to solve the problem of persistence storage layer, and it's a different way of approaching something like MySQL or Postgres because we use a non-relational model. So it's document-oriented, open source, performance. Oh no, sorry, here we go. So it's document-oriented, open source, high performance, horizontally scalable, full featured. It's a lot of buzzwords. It's a little marketing-y. So what do those things actually mean? So document-oriented. The most important thing here is that it's, we're not talking about PDFs or Word docs. It's actually supposed to be, basically JSON objects. Although more specifically, we don't use JSON. We actually use a binary representation of JSON called VSON in order to store the data. Open source, this is actually something that's pretty important to me, especially people who are going into the workforce possibly at some point in the next few years. I think it's something that you all should consider is finding a company that does open source software. And even if their primary product is an open source, you should keep an eye out for companies that release, like Twitter released Bootstrap and things like that, companies that actually care about the open source ecosystem. It's cool. And also worth pointing out from kind of like a business perspective is that we follow what's called the Red Hat business model, basically, which means that we give the product away for free, and then we offer consulting and support in order to pay the bills. And up until, 5-10 years ago, maybe, that was just non-existent. That was crazy talk. And actually still when I'm talking with my dad, he still doesn't quite understand how it works. He still hasn't gotten his head around the idea that, that why would anybody pay you if they can just get it for free and then read things on the internet? And the answer is really just area expertise. And also the idea that when you're paying for a product like that, you're actually contributing money in to make the product that you're using better. So we offer all kinds of support and everything around that. And also we're up on GitHub. So if you want right now, github.com/MongoDB/Mongo is the project. You can go check it out. You can fork it. You can start to edit it and put contributions back. I will say though that we're not, it's a very, very deep code base, as you might imagine, as a database. And it usually takes our engineers somewhere from 3 to 4 months before they're really actually able to commit real code. So chances are, if you look at it for 10 minutes and then start opening pull requests, they might not go anywhere fast. So high performance, that kind of feeds nicely into, it is written in C++, so we actually use memory map files, which relates to the usage of the database itself. So one of the things as you go beyond, weekend hack project to I'm building like a real scalable system, one of the things you'll find is that you need to make sure that your working set is all kept in memory. That's the way that we usually explain it. And what that really means is that all of the documents in the database that you're going to be, like the full range of documents that you're going to be touching, reading and writing within the database really has to be kept in memory. Because if it isn't, then you have to go to disk in order to grab it, and that is incredibly slow, and that sort of speed can start to catch up. Those kind of locks can start to catch up with you after a time, and it can cause real application level issues. So that's one of the reasons. But when you actually do keep it in memory, it's incredibly useful. So what happens when you, so VSON is mentioned there. What happens when you actually start to exceed the number of, the amount of RAM on this first machine that you're using? It's horizontally scalable. So anybody here heard the difference between horizontal, anybody here not heard of horizontal versus vertical scalability when it comes to hardware? Okay, so vertical scalability literally means buying a more expensive machine. If you're using a company like Oracle, who is really one of our major competitors in space, you spend $500,000 on a new like Exadata machine or whatever it's called, and it can handle more and more. Nowadays, though, with the advent of AWS, everybody likes horizontal scalability. You just grab a bunch of more small machines and throw it at the problem. Which means that what we have is a distributed system, and there's a lot of complications that come along with that, and we try and abstract away a lot of the complications so that, if you have 5 servers and your data is split across all 5 of those servers, we try and do as much as we can in order to abstract the problem, and you talk to a single point of communication, and it handles the routing of requests for data to whichever of the 5 machines you actually are supposed to be talking to. And then fully featured. I would say out of all the things we've been doing, this is the one that we've probably had the most success at, and that's really kind of developer comfortability, I guess. Just really making it so that you can drop in and start working with Mongo as quickly as possible. And so that's also what I'm going to be showing you most of today, because while, scaling out your system through sharding and replica sets is pretty awesome and fun to play around with, it's probably not the point at which you guys are at. Although I'll touch on it a little bit for anybody who's particularly ops-minded. MongoDB.org/downloads. Download it. You can also homebrew it, and it'll get you 2.2.0 if you like. You can also just not download it and follow along with me if you want. It's, kind of up to you. So I should also say, any questions so far?
Sorry.
Yeah.
When you were saying about the horizontal and vertical scaling.
Yep.
What is SQL? I'm just curious.
What is what?
SQL, like where?
Well, so you have to be, terminology is tricky.
Right.
SQL is really just a language, right? So SQL itself is just the manner with which you interface with MySQL, MariaDB, Postgres. So most relational databases which you access through SQL do provide a means to scale horizontally. It's usually called partitioning. However, you usually have to keep the partitioning logic at the application layer, which means you can store your data across 2 different machines or 5 different machines, but your application itself has to know on which machine your data is stored based on some kind of range of keys, for example. The best way to think of it is, you're storing all your user data and you partition on last name. First off, it's probably a bad idea because you're going to get lots of clumping on machines around like the letter S and the letter T or something like that. So you would shard along that, but then your application would have to know that everything from A through D is over on this machine, etc. And a lot of those systems have started to deal with the same problem as well. It's Oracle's machines are actually the ones that are most notorious, where you really get to industrial level software that they start to pitch, warehousing software, stuff like that, where Oracle comes in and pitches a massive machine. So yes, like most relational databases, aka SQL databases, do have some kind of partitioning, but we've tried to, take away as much of the pain as possible. So yeah.
I'm hearing about SAP HANA, like the in-computing memory thing.
Have I heard about what?
SAP HANA project? Like,
I don't know it. What's it?
So it's in-memory computing. So I'm just wondering, is it the same as MongoDB? Like you guys, because you mentioned like the computation was done in the memory instead of hard drive.
It's taking the same approach to solving a problem, but it's not actually a competitor that I know of. I don't know, ask me afterwards, we can Google it, I guess, and try to see. So download. Yeah. Okay, so everybody download it, you untar it, and before we actually go into using it, I just want to talk a little bit more about this document-oriented stuff. So for those of you who sort of get some terminology out of the way, usually you're used to hearing in a tabular database about tables. We have collections. Collections are a little bit closer to something like a namespace is the best way to think of it. Instead of rows, we use documents. Indexed are the same. So this one's a little tricky. Instead of joins, well, we don't really have joins. I'm going to come back to that and talk about it a little bit later. But the core idea behind MongoDB is that you change your data model. The way that you store things is different. Foreign key, we use references, and I was talking a little bit about partitioning. We call it sharding. So I mentioned the data model. This is what your typical data model will look like if you have to build some sort of blog engine in something like Postgres. So you've got a different table for every single object, and you've got columns within each table, and you're probably using some kind of ORM in order to pull all the data back together so that when you ask for an article with comments, it actually does all of the graphing for you. So we have a slightly different approach, and the idea is you actually store all the data together. So what that ends up meaning is that writes can potentially be a little bit more expensive, but reads are significantly less expensive when it comes down to it. So instead of having to join across all these different tables, grab the data from a bunch of different places, it's literally all stored together and pulled out. One of the other things that I think has been really important to why people seem to love the software is because it is in BSON, which is basically a form of JSON. And JSON is incredibly popular right now. Like, there's actually another database out there called MarkLogic that does a lot of similar things that we do to XML, but they do it in XML, and nobody has heard of MarkLogic. It's just because XML is kind of just fallen off the map.
Isn't CouchDB somewhere like what they also use JSON?
Yes, exactly. And you've heard of CouchDB, but probably not MarkLogic. Yeah. And the whole CouchDB ecosystem is really bizarre. There's like 40 different projects that share the Couch prename, and I think Couchbase 2.0 is coming out at some point in the future. And so Couchbase used to be a key value store, a little bit closer to something like Redis. And they are actually pivoting entirely, and they're turning Couchbase into a document store, which is kind of, for us, it's like simultaneously scary because it's another competitor, but it's also kind of awesome because it says, oh, right, so we definitely made the right choice to go this way, and we did it a while ago. So it's actually a kind of a weird twist that you can look for in the next few weeks. So this is the difference between Postgres or MySQL and Mongo, or really any other document-oriented store. So what I'm going to go through and use as the sort of framing subject here is a library application, but it's going to be a little bit weird because I'm going to be showing you things through the shell. So we have MongoDB Shell. It's where you can do kind of all of your administrative tasks as well as futzing around. And it's also not even close to anything like what you would write a real application in because it's just a shell interface. If you were writing a real application, you'd be using Python, Ruby, Java, whatever, and you'd be using one of our drivers. And the drivers basically provide the same interface to MongoDB, but we try and do it using all of the, the particulars of the language that you're using. So if you're used to using, .NET, right? .NET has this thing called LINQ, like LINQ. We've got the LINQ support built into the .NET driver in order to just make it that much easier. Any other questions about sort of data model or the terminology that we're using? No? Cool. So, right. With your data model, you got a lot of random stuff, and usually with a application like MySQL, you're going to have to define a lot of that ahead of time, and you have to do migrations as you're trying to decide, as you change what you're going to do, and in a way, it's not terrible. Migrations aren't the end of the world. However, I think like the one example is Craigslist. So Craigslist actually stores their entire archives in Mongo now, and the reason for that is that they used to store it in MySQL, and Craigslist has been around for so long that every time they went to change a single column, they found that it was going to take like 9 months to do the migration. That's a bit of a problem. So nowadays, I think they have the most recent X, and the reason that Craigslist, if you don't know, is amazing is that you can still go back, and if you have the URL, you can access every single post that has ever been made on Craigslist throughout the past. It's probably been around for 12 years at this point, 15 years maybe. It's been around for a while. So, and that's actually kind of nuts. People always talk about Facebook scalability and like Twitter and stuff, but going back that long in history is pretty interesting. And so MySQL was blocked from doing that, so they're keeping their up-to-date stuff in, I think, MySQL, and then all their archives are over in Mongo. So that's one reason that, migrations can actually be a pain in the ass. So with us, right, we're actually just going to start building, and then you can change things, and change it pretty easily. So chances are, with a library application, this is what we're going to be looking at. Users, books, authors, and publishers. And honestly, I'm only going to use like 2 of these 4 just because it's all I need to demonstrate a bunch of stuff. So, now that I've got that, I'm going to switch over. Did everybody who wanted to get Mongo downloaded? Cool. Which way is this? Yeah, here we go. So, oh, nope, I'm not going to be able to do that, am I? All right, awesome. So, okay, so from the directory where you've actually untarred it, you've got all of these things. First thing you want to do is just start up the server by running /MongoD. Or, if you've just installed it with Homebrew, then you can just run MongoD. Anybody get any permissions issues? No? Excellent, good. So, that's usually, when in doubt, if you're having trouble with your OS, it's probably a permissions issue. And then, in order to get into the shell, /Mongo. And that'll put you in. So I am actually running a slightly modified version of the shell. For those of you who are interested, you can, one of my coworkers, Tyler Brock, has a thing up on GitHub called Mongo Hacker, and it basically provides a colorized shell. It also tells you what version of the DB you're connected to, and it also tells you what database you're using right now. And actually, I have. Yeah, question?
I've started through Homebrew and I don't get anything when I type /Mongo.
Okay.
You can just do Mongo, I think.
Yeah,
It's
so
solved on Homebrew.
yeah, so
You have to open
/.
a new tab so that you get the source. Open a new window.
So the thing, // is going to try to run a MongoD executable in whatever directory you're in right now, and you're going to be running it from some path that's probably user live something something. So this is working.
So what directory should I be in?
You should be able to actually run from anywhere, just MongoD, not even typing /. Is that going?
Yeah, no, it's saying where it's logging to.
Okay, cool. Yeah, exactly. It's probably like data/db/journal, stuff like that. So there we go. We're up and running, and we're in the shell. All right. So first thing is, we mentioned terminology before, right? Show DBs is and there we go. That should be a little bit easier. So all right, show DBs is going to show you all the databases. And so I know right now that I'm using test. However, if I wanted to switch to it, I can just do use test. So that switches you to DB test. I'm actually going to use library. Now notice there's not actually a database named library yet, but we're going to create one in a minute. And I also need to shrink this again. Don't want stuff running off the page, sorry. All right, let's read. So within the library, you can actually do show collections. And right now, there's nothing, right? So we don't have any of that kind of equivalent of tables right now. And the first thing we're going to do is we're going to add a user to the database. So I'm going to do db.users.insert. So db just means, okay, we're going to be inserting this into the current db. And users is the collection. So there is no collection yet, but we're going to create one automatically. And insert is the first and arguably most important thing, since you got to get your data in here somehow. Like I said before, this is going to be a CRUD app, right? So create, read, update, destroy, delete. This is the create part that I'm going to show you right now. So db.users.insert, and it's going to be parentheses. And then we're also going to use curly braces. So just remember, everything here is JSON. So now you're just going to pass in a JSON object. So let's do my username, Ian.Whalen. My first, easier. Oh, here we go, so much easier. First name, Ian. Last name, Whalen. Inserted one record. That's it. Now you've both got your database called library, you've got your collection called users, and you have your first object in there saved. So one interesting thing is that you might notice that that insert actually took 378 milliseconds, which is an ungodly long time in database terms, and that's because it's the first object that you're saving, and so it's got the overhead of creating the database and the collection and everything. So in theory, the other changes should take a lot less time. Also, but you might not see like a bunch of these things like that. Inserted one record in X time. I think it might not show that for you guys. I think that's just coming from Mongo Hacker. It's like a really nice little plugin. I keep urging that we merge it into the shell. We'll see if we do that at some point. So how do you get your data back out? Pretty easy. Once again, you're going to use the current database. You're going to look into the current collection, and let's do find. So what that's going to do is actually return everything in the user's collection. And so you can see here, username, first name, last name. We've also added another field, and that's the _ID field. For those of you coming from the SQL background, that's basically your unique ID. If you don't provide one when you do create an object, we create one automatically. However, it's something that you can also generate on your own, as long as you know that it's going to be unique. So for example, I'm going to show you a little bit later, I've got a zip code collection in here, for which I'm using the zip code as the unique ID for the object, because I know that that's going to be unique. Also, I forget...
Is there any particular format that ID is that?
Yeah, so
type?
yeah, I can actually pull this up. I always forget the exact order of these things, but I can even show you. Oh yeah, here we go. Unhide and yeah, here I snipped this thing out because I didn't think it was that interesting before. But actually, so this is actually the object ID. It actually contains a ton of information. So one thing, for example, is it contains the timestamp that the document was created on. So so this is like a minor hack that you can use if you want to. If you want to be safe, you can skip this, but you can actually use the ID and parse it in order to extract the created on date for each object. It's also got the MAC address and process ID for that specific thread that created the document. If we need to track kind of how that document got created in the first place. So yeah, and also pro tip, that means you also don't necessarily want to shard on the object ID if you're trying to build a horizontally scalable system, because it's going to be a naturally increasing object. It's going to be a naturally increasing value, which means if you are sharding on that, you could potentially end up with the majority of all of your reads and writes going to the last partition in your sharded setup. Does that make sense? Because every time you save, what you want, if you have like a horizontally scalable system, is for an even number of reads and writes to be going to every single machine, but because things are going to be saved based on this ID, everything is going to go to the very last one. Probably not that necessary until you're really hitting huge scale, but it's something that I've seen bite some people in the ass before, so I don't know, I think it's interesting to know. So fine, that's the read part, but it gets a little more complicated than that. What you can also do is you can do find one, and what that's going to do is return it in a slightly prettier format, which, once again, this is pretty useful for the shell when you're just messing around. It's also going to pick up the first thing that it encounters on disk. So right now, that doesn't matter because we're just only got one document in this collection. But as you get more and more documents in there, if all you really, it's basically a limit one. So if all you need is one document, you can use find one. However, everything here is also JavaScript. So let's do username equals John Smith. First name, God. Yeah, exactly. Told you. First name, John. Last name, Smith. Great, so we have now saved a user variable, and now let's do db.users.insert user. Insert one record. Oh, it was 1 millisecond. Good. So db.users.find. Now we've got 2 records. db.users.find 1. We're still only pulling back 1 record, and we're still just pulling the first one off of disk, which is basically going to be insert order, except, I don't think I want to go into this too deeply, except that we sort of allocate space for every single document as it goes in. And one of the cool things about Mongo is that it's a schemaless data store. I actually didn't really talk about that before, which is kind of silly. So I should review that right now. Let's do this. User equals that, and job is engineer. So insert. Great. So for those of you who are used to SQL, this is where we come to the whole, you can add things without having to worry about changing at the database level. So I'm saying that really, really specifically. You can change things without having to worry at the database level. Your application, however, needs to be aware of it. And this is kind of the awesomeness and the power and the responsibility of using a schemaless data store, is that your application needs to know that there might or might not be a job field when you go to query for a user object, and you need to handle that appropriately, or else things are going to break. Does that make sense to everyone?
I mean, it also means that if you mistype a field ID that you're gonna...
Yes, it will. If I had typed user nam instead of username, boom, that object has been created. Collections will also get created without a response. So it's really nice. It can also bite you in the ass, so like be aware of it. Also, so show collections. Right, you can see that the user's collection was created. So db.authors.insert. Let's do first name. Seems appropriate. Last name. And let's do bio. Music writer. Yeah, looks good. Great. So, so interestingly, I guess it's just, I didn't even realize that it's just allocating the space from the database itself that takes up all the time, because we just created a new collection and it took basically no time. So now we've got a users collection and an authors collection, right? So once again, just kind of reiterates the whole powerful but dangerous sort of message. So now we do, how do I get that entry back out of the database? Anyone?
Select.
Nope, no selects. Bad engineer. Go on, someone's got to answer. What is it? How do I,
Find with something in it.
Sorry?
Find with something defined.
Doesn't even need to be. So it can really just be db dot what? Authors dot
Find.
With oh no, actually here, let me see. This should. So here's another interesting thing. If you leave so what you said, everything is in JavaScript, right? So if you leave the parentheses off, this is actually a really useful way of telling what's going on under the hood. For anything in the shell, you can leave the parentheses off, and it'll actually tell you what it's trying to run. That's not really, and also I probably shouldn't overemphasize like the danger stuff too much, because chances are you're never working from the shell. You're really working from an application that's written in something. It's using either one of our drivers or even an ODM, which is our version of them. Instead of an object relational mapper, it's an object document mapper. There's a bunch of them out there that you might use. So you can effectively create a schema at the application level pretty easily. And you're never going to be writing like db.authors.find for a real application. So yes, db.authors.find gives you that. And you can also return it back out in a slightly prettier manner by doing what?
Find one.
There we go, exactly. If the whole question and answer thing gets lame, just tell me. I kind of like to make sure that at least one person in the room catches on to what I'm saying, though. So here we go. Find one. Just returns a random one and does the pretty print. So now I'm actually going to cheat a very little bit, and I'm going to paste something in because you don't want to sit here for the next 10 minutes while I try and type something out. So I'm going to put it in a book. Okay, so first what I'm actually doing is I'm just creating the variable book. So you can see we've got title, we've got author, genre, language, publication, and then publication name, publication location, and publication date, and enter. So this is actually introducing a bunch of new things that are worth pointing out. So the first is that we are using something that's really similar to JSON, but not exactly. It's BSON, right? And BSON has a couple of extra data types, one of which is the object ID, which you've already seen up here. Oh, damn it, actually. And exactly, because I typed this out earlier and I pasted from something else. So what I'm actually going to do is that. There we go. Would you believe I actually have written in my notes in like caps, remember to change the object ID? It's pretty odd. So first off, object ID. Second, arrays, right? So array is data type in Mongo that you can use at an item, basically. And the next is the embedded object type. So you can see publication is actually another object that contains a whole other series of fields and values. And then we also have the date type. So let's say I want to put this in a books collection. All right, I'll spare you the quiz. It's tv.books.insert book. Ooh, it's in there. One. So here's a slightly prettier way of looking at it, right? And it also includes the indentation, which is nice. So this is kind of cool. And now this is what you can maybe start to see when I was talking about how your data model has to fit with the problem that you're trying to solve, and you're not going to do kind of the crazy sort of normalization that you're doing in a relational database. You're going to, let's say, if this were a blog application, if this were a post object, you could have a field that was comments, and then have that be an array. And then within the array, just append every single time somebody adds a new comment. And then when you go to do the reads, then everyone will, and when you go to the reads, every one of them will be pulled back out with you. So one of the obvious things to keep an eye out for is that, let's say in your comments, you're also displaying the username. Let's say somebody goes in and changes their username in your blog application. Because you're not, so when you're normalizing your story, you're trying to minimize the number of places that you're keeping all of your data. In theory, it should only be kept in one place ever, anytime. So now you're storing usernames all over your database, which means if somebody goes in and does an update to that, then you're going to have to go and somehow do an update throughout the whole database, which can be expensive. At that point, it's a matter of gauging what your application is trying to do, judging the trade-offs, and making the decision accordingly. Because, and so I can actually tell you, Business Insider, which I actually hate as a site, but they do use our software, so I have to like them a little bit, I guess. They basically store multiple copies of everything everywhere, because you're doing your application is going to be reading blog posts from the database far more frequently than anyone is going to be updating their username, right? You know, the editing a username probably happens 20 times a day max, and they're probably trying to serve out God knows how many page views. I'm sure to be embarrassed for the world to know how many page views they're actually serving out. So it's a thing that you need to take into account and make your decision, and then design things accordingly. And so this really goes back to what I was saying before with that one slide about how you start building an application and then you iterate on your schema. Everything has to do with your read and write patterns. So you start building, you get this thing out in the wild, and you build something that has all of your comments in one post, and then after a while you figure out that actually people are editing their comments or editing their username infinitely more than you thought they were going to be. It's a problem. You adjust. Then you start moving everything, and then what they actually do is kind of like a find and modify sort of, where I believe when you go to do a read if the comments are not in a separate, so let's say you've got all of your comments in the same collection, and then you're trying to move them out to a separate collection, rather than running a huge job to go and just move all the comments out and replace it with a reference like you see here. I think what they do, don't quote me on this, I think what they do is they actually just have written their application so that if it goes to find the comments for that specific post, it's not there, then they go and they find the post object, pull out the comments, put them into the comments collection so that now it's there, and then they render it. So like the first time that somebody goes to read that thing, it'll be a little bit of extra work, but it'll prevent them from having to do any crazy site downtime or really any extra work on posts that are never getting read. Which for them, right, all of their stuff is in the 24 hours, right? Nobody probably ever goes beyond 72 hours on a site like that. You had a question?
Yeah, is there any easy way to track which things are being, or like which database columns are being edited most often within Mongo, or would you have to do that in some other part of your code?
So which database columns are being edited? No, not to my knowledge. So in a way, what you're looking for is kind of auditing. So we have logs, and so you can take the logs, but we don't have any kind of counters built in that increment every time you actually do an update. So yeah, a lot of it is really just going to have to do with your site responsiveness. Actually, if you start to notice that a page is loading slow, then you pull up your dev environment, you simulate what's going on the live site, and you see which calls are causing it. We do also have slow query logging, which is kind of maybe going to, it's not specifically what you're looking for, but it might address the same problem, which is identifying what is going to the database, what is causing problems round tripping to the database. So did I ever actually insert that thing? Yeah, good, I inserted it. So awesome. That's finding, that's data types. Oh, you might also notice that this is what I did the new date as, and then this is what it actually gets saved as an ISO date. So what if you want to find something specific? So d.books.find one where, let's do language English. So there we go. So that's pretty much your equivalent. So far all I've been showing you is basically select star and select star limit 1. So what this is select star where language equals English, or in the second part, NGish. So what you also probably want to do is select specific columns, actually. So the syntax, actually, here, you know what, I'll probably even show you. Sweet, so query, fields, options. So you can see up there at the top. So what you're actually going to do for the find one, so this is kind of the select the where statement, and then outside of the curly braces, actually, can you guys actually all, you know what, I just realized, let's pull that up a little bit, is that a little bit easier, hopefully. So let's do English, and then let's do, yeah, publication. Publication 1. So, the syntax here is really just 1 is true, 0 is false. So now you can see what it did was it always returns the object ID, and you, in this case, have constrained it down to just the publication field. You can also do is, let's say, genre. There we got the genre array, or author, etc. So that's how you do your basically, that's how you do your select star where x equals y, and I actually forget what the SQL like limit of the columns is.
How do you do like
Limit.
date is less than something like it's another date?
Yeah, so actually that's a good one. Let me get the doc back up here, which was our
And you could do
format.
multiple, you would just combine them.
Yes,
Commas.
yeah, exactly. Sorry. So you can do, author, publication, one, author and publication. Okay. Let me just see. Yeah. So this is what it looks like. So you can also sort of inspect into subdocuments. That's what like the publication object we call subdocuments. So you can actually inspect into there. So let's do db.books.find one, and we're gonna do so I believe you actually have to put this inside of quotes. So we use what's called dot notation. So let's actually do publication dot location is London. Boom. Okay. So x dot y gets you inside of objects, and so you just said.
The comparing dates.
Yeah, so what you want to do is publication.date. And now, here's where things start to get complex. So you're going to want to do dollar. So we have things called dollar operators. So if you go on the MongoDB manual pages, we've got lots of them. I'm going to show you, 4 or 5 more examples, I guess, just to show you what kinds we've thought of. In general, though, it's just, for manipulating data. So this one is you want publication.date is less than, actually, new date, and what did we actually insert here? Here I have it over here. Okay, there we go. So new date is less than June 1960. Because nope. Damn. Syntax.
You need a
Quote.
quote.
There we go. That's good. So publication of date, dollar less than, new date, close, that one closes that, oh, I need one to close that, and then that looks good, right? Boom, excellent. So, as you can see, less than works, and in theory, greater than does not. So that's how you're going to inspect against dates.
That's the default date format that recognizes?
I think it recognizes anything that works within JSON. So that's the way that I usually do it. I'm pretty sure you can just pass in an ISO date as well. If you want to construct that, honestly, I'd have to look up the JSON spec in order to remember exactly, because I think there's a couple of different variations, and okay.